Hi, my name is Annika Edgington, and today I will be doing a tutorial on how to find the mean, median, mode, and standard deviation by using a graphing calculator. For this tutorial, I will use a TI-84 Plus Silver Edition. The mean, median, and mode can be defined as the measures of central tendencies. The mean is found as the traditional average, which is given by the formula of the sum of all A divided by N, where A is all the values in the set, and N is the number of values that are in the set. We can find the mean in the average, or the average of the set of numbers as follows, the 1, 3, 4, and so on, by plugging into the calculator. So we will go over to our calculator, press on, and then the sum of all the A's can be defined as 1 plus 3 plus 4, and so on until we get down to 30. And as I'm putting this in, I see that 22 repeats twice, while all the others only repeat once. So that gives me that the mode, or the most occurring value in the set of numbers, is 22. So as I finish up, we can see that the sum of all the A's, or the values of all the values in the set, is found by 260 as the value. But that's not the mean, because we still have to divide by N, or the number of values in the set, which there are 17 numbers, so we're going to divide by 17. And the mean, when rounded to 3 significant figures, is 15.3. Now to find the median, we don't need to use a calculator because we can use the cross-out method, where you cross out one number on one side and then the matching term on the other side. And we keep going as we cross out second terms, third terms, until we get to the middle value, which we can find as 18 when we cross out all the beginning values and the end values to get to the middle value of 18. And as I already said, the mode, which is the most occurring value in the set, is 22. However, all these values can be found a little quicker by using the stat feature in the Texas Instruments calculator. To do this, we will follow the steps given here, numbers 1 through 13. So after we turn on the calculator, we're going to hit Stat, and on number 1 here on Edit, we're going to hit Enter. In L1, you can see that I've already put in all the data for this set. However, if you have other numbers put in these lists, you can scroll up to L1, hit Clear, and then Enter, and it will clear your list of data so that you can put in all the values given here. We can make sure that all of L1 has the same number of values in the data by scrolling down and seeing that our last value, which is 30, is in L1 on the 17th place. This is really important so that you make sure you don't get extra or miss a value. Next, we will go to Stat, and then scroll over to Calc for Calculate, and hit 1 var stats. On Enter, then the list, or our sets of data, will be in L1, and for this data we do not have a frequency, so we will leave this part empty, and if you have an L2, L3, or anything in there, then you just press Clear and Enter. So we're going to scroll down to Calculate and hit Enter. And mean is given by the X bar, which is 15.3 when rounded to 3 significant figures, which we found in the earlier part by using the formula. Similarly, if we go down to where it says MED, or median, we find that 18 is the same value that we used when crossing out the ends and the beginnings. This does not give you mode because it can easily be eyeballed. So we can also see that there are important other informations in here, such as the sum of all the X, which is what we got when we added 1 plus 3 plus 4 plus 5 and so on till 30, before we divided by 17, which was the step in getting to mean. Additionally, we can find the sum of all the X terms squared, which is important when we find standard deviation, which will be in the next section. So keep this term in mind when we are going to look at the formula for standard deviation. Additionally, standard deviation can be found in this list by the lowercase sigma x, and we'll see that it is 9.3, which we will prove in the later section. We can also see that the number of terms in this set of data was 17, as we used in the end for the sigma a divided by n when we found the mean. So now we will talk about how we find standard deviation. Standard deviation measures the spread of the data, which means it measures how far the extremes of the data, or the high and the low, are from the median, which can be given by this equation, where s squared equals the sum of all the x terms squared over the number of terms minus the square of the mean. Now, standard deviation is given by just s, not s squared. So when you find standard deviation, you'll have to square root the answer from this equation. So to find the standard deviation using the same set of numbers that we have used before in this equation, we will go second and mode to quit out of that screen, and then we will plug numbers into the equation. So first we're going to do all the x terms squared and add them together. So the first x term squared would be 1 squared, and then we're going to add them together, so it would be plus 3 squared plus 4 squared, and so on until we get to 30 again. And I made an error there, so I'm going to go ahead and delete back so that I can put in a 22 and square it instead of just 2 squared. So it's really important that you watch as you're entering in data values, because if you don't, you can really get a different value for your standard deviation. And finally 30 squared. So again, this is the number that we saw when we did the stat and calculate, and I told you was the sum of the x squared, which is 5,452. Now the next part of the equation is to divide this value by the number of terms, which we found was 17. Then we are going to subtract the square of the mean, which we found is 15.3. And we're going to square that. And this value gives you 86.6, which is the value of s squared, which is not standard deviation because standard deviation is just s. So we're going to do second and then the x squared button, which will get you the square root of your answer, which can be used by doing second and -1, or the negative sign, and then hit enter. And we'll find that using this formula, standard deviation is 9.31 when rounded to 3 significant figures. Now this was really tedious and it was easy to mess up, as you saw that I did, so we can do this in the stat feature on our calculator as well. And we'll follow these steps 1 through 11 over here if you would prefer to follow along over there. So we're going to go back to our stat feature and hit edit. We still have the same values in the L1 because we're using the same data. So we're going to go back to stat, calculate, and one var stats again, with L1 as our list or our data. And if you don't have L1 in there, it can be found by pressing second and then number 1, which will put in L1 for you. We want to make sure that the frequency list is clear, and then we can hit enter for calculate. And standard deviation is denoted by this lowercase sigma x, which is also 9.31 when rounded to 3 significant figures, as we found in our equation. Now we can use this idea in the features on our calculator to calculate the standard deviation and the other median, mean, median, and mode by using the calculator in more complex problems. So the next example is to find the mean, median, and mode and standard deviation for the following data. The number of customers served lunch in a restaurant over the period of 60 days. So these are the ranges of customers and then the numbers of days that they were served in the 60-day periods. So in this instance, this set of data over here will become our frequency, while this set over here is our ranges. Now it's not ideal to put in range into your calculator because this will act as a minus sign instead of a through sign. So we want to be able to find the mid-interval value, which is used to estimate the number of customers in each group. So we're going to find this by using 1/2 times the low value plus the high value. In this set of data, it is discrete, which means that only whole numbers make sense, which can be used in counting numbers of people, numbers of tests, where you don't have decimals. However, when we find the mid-interval value, it may come out as a decimal because you're going to use the lower number in the first range and then the upper number in the same range. As opposed to in continuous data, when you want to use, for example, if this was continuous data, you might want 29.9999999 and so on. So you would round up to 30 so that you can include all of those decimals. However, since all of the data you're working with right now is discrete, we only want to use 29 because you would never serve 29.9999 customers. So we will find the mid-interval value, which will be put into our L1, and you can see how it's been found here using the 1/2 times the lower value plus the higher value, in this case 20 and 29, to find 24.5. So we're going to go to our calculator and hit Stat and Edit, and we're going to clear out L1 by going up to L1 where it's highlighted, clear, and then enter. And then we're going to enter our mid-interval values into this section. So it's going to be 24.5, 34.5, 44.5, and 54.5. And then 64.5, and finally 74.5. This covers all of our ranges, so then we're going to scroll over to L2 to input our frequencies, which would be the number of days in the 60-day period. So it's going to go 6, 12, 16, 14, 8, and 4. We are then going to go back to Stat, Calculate, 1var Stats, and make sure that in the list our data is in L1 and our frequency is in L2, which we can input by clicking second and 2 to get the L2 in there, and then scroll down to Calculate. This will then give us the mean, which is given by xvar, and is 47.5. Our median is then, scrolling down, 44.5, and the standard deviation by the lowercase sigma and x is 13.7. And the mode would be in the 40 to 49 range because when we were looking at it, there were, as you can see here, 16 in the 40 to 49 range, which is the most. This isn't given by the calculator, but as you can see, can be given by the frequency list, and the highest frequency would give you the mode. For our final example, we're going to look at a set of data where you would have continuous data. Since there is age, someone who would be 14.99999 years old would still be considered to be 14, but we still want to include them in our data. So for this one, to find the mid-interval value of the age groups, which is the population of a small country town, we will use the higher value or the lower value of the next range. So for the mid-interval value of the first age group, which is 0 to 14, we will do 1/2 times 0 plus 15, which is 7.5. Likewise, for the next group, which is 15 to 29, we will use 1/2 times 15 plus 30, which equals 22.5. And we will go continue onwards. And that's how all the rest of the values were calculated in this table. So we will do the similar process where we hit Stat and enter on Edit so that we can redo our data in here since we have new sets of frequencies and of data. So we're going to clear out L1 and L2. And in L1, we will put in our mid-interval values of 7.5, 22.5, 37.5, 52.5, 67.5, 82.5, and 97.5. Next, in our frequencies, we will put 856, 1120, 1054, 792, 651, 288, and 96. We will then go Stat, Calculate, 1var Stat, with the data in L1 listed as the list and frequency in L2. We'll then go down to Calculate, and since we are only looking for mean, which is 39.1, and standard deviation is 23.6, we have found all the data we need. Thank you.